Hello everyone, welcome to part 2 video of Netflix data analysis using Pyspark. So let's get started. In the previous video, we actually saw the data project question, like what kind of data we have, and we were given some few questions, and also at the same time to provide insights based on the exploration. And then after that, we did a setup and import, and then we actually saved data that is actually the demo data in volume, the managed workspace, so managed volumes in Databricks. And after that, we did some data cleaning. We did actually remove any white spaces in the leading and trailing, and then we actually filled missing values with unknown and NA, and then we converted date to the YYYMMDD date, and then we actually did some duration cleaning to have like what actually like whether it's minutes the type, and then we separated the integer part from the duration, and then we dropped some duplicates in case if exists show ID. And then after that, we did exploratory data analysis. So exploratory data analysis, we actually tried to see the number of missing values still exist after we filled in missing values for some of the important columns. And then post that, we actually tried to find the distribution of TV shows and movies in the data set that we have. And then we actually found out that, okay, let me tell you that currently, if you look at this result, you can see that there is actually difference in the number of movies and TV shows, like the proportion we had in our part 1 video and the part 2 video, because when actually I later found out that the data is, because it's actually a demo data, it's not a real data set. So what we did was actually we were mimicking the real data set, and it was when I compared, it's usually like the movies number should actually be much higher than the TV show. So because TV shows like actually started getting exploding number in recent years, so that's why now what I have done is actually like I changed the data set a bit, like it's actually 1500 rows, but the proportion is a bit changed. So if you look at this, and then we did some top countries, and I don't find any difference. In top countries were United States followed by India, were actually at the top two, and South Korea, Japan, Brazil, so there are actually other countries as well. And then we actually found out the top genre, and then after that, we actually try to plot it like the top 10 genres. And then we actually try to see the release year trend, whether the number is increasing by year. And if it, when you look at the numbers, it actually, I would say it's very similar to the real data set, where actually by year we know that it's actually increasing, even though there is a bit of like change in number, like in if 2015, if you see like the number was higher, and in 2016 it actually reduced a little bit. So that happens, but otherwise the trend is in an increasing manner. Okay, so the EDA we did actually stopped at this point, and then I was talking about exploring the questions and also like getting insights in this for the session. So let's start with that, and I think let's start with questions. So if you look at this here, we actually have nearly 6-7 questions where we had actually like what type of content is available and what type of content is available in different countries and how has the number of movies changed over last 20 to 30 years. We have more than that, but we are actually considering 20 to 30 years, and then comparison of TV shows versus movies. And there is a question about the best time to launch a TV show, uh, and then analysis of actors or directors of different types of shows or movies. So to check the top actors or top directors on shows or movies types, and then it's asking whether the focus on TV shows more than movies in recent years, and understanding what content type what type of content available in different countries. So let's start answering these questions. And the first question is what type of content available in different countries? Okay, let me just. Here we are, and we need to see like the type of content. The type here mentioned is about like whether it's a movie or TV show. So we will analyze the TV shows, movies, kind of like how their distribution varies in different countries. So let's first do it after doing the splitting of the country column, so that we get, and we also need to do the exploded thing, so that like we actually get them in different rows. So let's say df splitted is df dot with column, and here I will actually name it df country, where the country is going to be split off call of country, and then we will check for the delimiter, that is comma. And next thing is, like I mentioned, it's actually the explode the array to get all separate rows. So df exploded is going to be df splitted dot with column country explode of call of country. Okay, and next thing we while EDA also you might have seen we do trim to trim white space, and how you can actually do it. Df trimmed is equal to df exploded dot with column and country trim of call of country. Okay, and we will actually because there are more countries here, we'll actually take the first top 10 and top let's say top 9, get top 9 countries. So it's going to be top countries equal to df trimmed dot group by country dot count. We will actually count because we need to then order it by descending. Count. and we will limit to 9, let's say. Select country. Okay, and the next thing is we will filter, and then we will actually get, after join, we will join it with top countries, and then on is equal to country. We'll do inner so that we'll only take the top 9. Okay, so that's it. Okay, now we have the subset. Now let's plot it to see that like how it looks like, and let's fig is, we will be doing using plotly. Fig is equal to px dot histogram. We'll use histogram to plot it. Subset dot to pantas, and y is going to be country, and then color is going to be of type. Bar mode is going to be of group. Title is going to be, let's see, movies versus TV shows by country. And then we'll use this color distribute sequence is going to be, let's say, px dot colors dot qualitative dot set to. Okay, and let's get the title and legend update. So how we'll do it, we'll actually use the fig dot update layout. Let's say x-axis title is going to be count, and then y-axis title is going to be country, let's say legend title text is going to be type, and then let's specify height and width. After that, fig.show. Okay, so here we can see that the green one is for movies and orange is for TV shows. And if you look at the top 9 countries, I would say it's actually the trend is similar, where you can see the movies actually movies actually outnumber that of TV shows, and yeah, so I don't see any change. There is actually, the gap is quite, I would say it's, I mean, gap between the number of TV shows versus number of movies, it's quite similar across different countries. Of course, the United States, the total number, I mean, the movies and TV shows number is, the gap is, the difference is higher. Yeah. Okay. So yeah, this actually Instagram helps us to see like what is actually the difference between or the distribution of different types of content in different countries. Okay, so the next thing, let's move on to the next question. So I'll just copy it from here. How has the number of movies released mark down and Q2. Okay, so let's start this. Let's actually get all the movies data. So movies is equal to df dot filter, where the df type is going to be movie. Okay, and let's count movie counts per year. Movie count per year. Let's calculate that. So movies per year is equal to let's say movies dot group by, and we'll group it on release year, dot count dot order by release year, and then for plotting we will actually convert it to pandas. Okay, so because like I mentioned in my previous video, like where I showed the number of movies or the number of, I think, the content release trend, when I showed it, like I was actually trying to show it using a bar chart, but I mentioned that to see the trend, line chart is also usually used option. So here I'm going to use the line chart, and let's say like fig is equal to px dot line, and we will use the movies per year data frame as the set is the source, and x is going to be release year, and y is going to be count, and then title is going to be movies released per year, markers true. Okay, and then I will actually a fig update layout. So x-axis title is going to be release year, y-axis title is going to be count, height let's say 500, and width 900. Okay, okay, so if you look at the movies released per year, you can see that there is actually up and down. I mean, all the numbers, let's say 2005 the number was 26, whereas like in 2006 20. It's not so realistic, but still it actually, I would say it's comparable or like similar to the real data, where of course the number of movies released per year is actually on the rise when you compare different years, like last 20-30 years. It's actually showing a very positive trend. So let's try to actually do the same for TV shows to see whether TV shows release also has an increasing trend or not. So I'm actually just copying here, because and instead of movies I'm gonna type shows, and here this filter will change TV show. Okay, and shows per year, shows per year. Okay, and the numbers shows released per year. Okay, let's see count. Let's try to. Okay, so if you look at the shows, number of shows getting released per year, that is also showing very positive trend. And of course, like 2020, there are actually some years where it dropped, but like then it picked up, so it's on the rise. If you look at 2023, and okay, there is actually a dip in 2024, but of course we need to understand that this is not the real data that we have, but it's actually on the increasing trend. And the next question, let's move on to the next question and let's see what it is. A comparison of TV shows versus movies. So let's try to understand that. And so it's the third question. Okay, so how to address it? I mean, we actually are trying to find out how many, or it actually, like, in a way, maybe okay, okay, so I think let's keep it simple, where we actually compare between TV shows and movies with their count, which we already did. So I think we can actually use the same. Yeah, okay. And we don't actually need to, okay, I'll just copy the same. Okay, and if you run it, I think I already showed this before, but like, yeah, TV shows, if you look at the percentage, it's actually like a 60, nearly 65 percentage of the distribution is actually for movies, whereas TV shows actually 30, 65, 35, so it's going to be 35, nearly 35, which is actually a kind of a one third, which is also a substantial number when we compare between movies and TV shows. So yeah, so this is a simple analysis to see how many in terms of count, like where they stand, like TV shows and movies. So let's move on to the next question. What is the best time to launch a TV show? This is an interesting question, depending on like how we actually. So is there a trend, and depending on the data, so let's see what is actually the best time to launch a TV show. Okay, so first of all, let's filter only TV shows. So let's say df.filter, where df type is TV show. And let's get month-wise. So we already have added month, which takes into account when this was actually launched in Netflix, the month in which it was added. So extract month data. So let's do the TV months. TV.filter, let's say TV added month. So we need to actually get rid of all the null values if any exist. So we don't have any, but still we'll actually taking into account that. So with column added month is going to be, let's try to get them into a okay, because we need to order it by itself from Jan to December. So let me just try to convert this into its integer number. Added month, and then let's cast int. Okay, and let's group by added month, then count, order by added month. Okay, and then to pandas. Okay, so after that what we're going to do is we'll actually get it. So we'll try to show it by in a line chart to see like how many shows, like what is actually the launching trend among different months, like what is when it's gets into peak season, when it's actually like little mid peak kind of. So we'll check. So line chart. So we'll use again plotly. Fig is equal to px dot line, and then TV months. Okay, and x is equal to added month, y is equal to count, and let's say title is going to be TV shows added by per month. Okay, and let's keep the markers true. Okay, and after that let's try to update layout. Also here what I'm going to do is, because we actually now have the added month as in integer form, so let's get it back to the Jan Feb order. So x-axis is equal to dict of, so x-axis will be having month, and then a tick mode is going to be array. So this is a way to provide where that ticks should be shown, like, and we will provide that in an array. So we'll be providing that. So tick vals is going to be a list of range of the 12 months. Okay, and we can use this tick text, which actually gives the value from Jan to Feb, March, April, May, June, okay, July, August, September, October, November, December. Okay, and then we can actually specify after this. Okay, that was about x-axis. Okay, I think I didn't mention x. Okay, and next thing that we're going to do is y-axis title is going to be count, and then height 500, width 900. Okay, then we will need to do the fig.show. Okay, so TV shows added per month actually shows from this data that we have, it shows that in if you look at the by quarter, the number of TV shows getting released in Q3 and Q4 are actually more than the number of TV shows getting added in, let's say, Q1 and Q2. So it shows that like December is usually this Christmas holiday season, and then Q3 also seeing a good number progress like July, August, September, and then October, November, December. So we can say that if we look at the quarter, Q3, Q4 are actually more favorable for TV shows release by looking at the data that we have. So we'll come to conclusions later. So let's keep this in mind and let's move on to the next question. So we are going to actually deal with question number 5. So it's an analysis of actors or directors of different types of movies or TV shows. That's question 5. Okay. So here, what I'm gonna do is I'm actually trying to have the top actors, top directors listed under types, shows, and movies to see like who are actually the trending or the most favorite actors or someone. I mean, like, or who have like this can be actually used when it comes to recommendation engines. They're more popular, they're actually acting in more TV shows and movies. So let's try to have that plotted. So for that, because we'll be having, let's say, TV shows will be having actor and director chart, and then movies will be having actor and director. So we'll be having like a total 4 charts I'm going to show. So for that, I am actually going to import graph objects as go, and also subplots, because we will be using subplots for this. So we'll import make subplots. Okay. Sorry. Okay. And let's first start with the process that we already been doing for, let's say, like when we calculated the top country, top genre. So all these cases we actually did first the splitting on the separate, I mean the delimiter, which is actually comma, and then we did explode, and post that we actually did the count of the numbers, and see actually took the top ones from that. So because we are actually we'll be doing that for types and movies and shows, and then actors, directors. So we'll just use a function. So I'm going to define a function top by type. Okay, df, and we'll have like call name, and then alias, and then n is equal to top 10. We'll get the top 10. Okay, how we are going to do it? We will actually, like I mentioned, df dot explode. So after splitting that specific column, call name on the separator, so we'll have it exploded. Okay, and post that we will actually with column we'll do the trimming, and we will use the same column name that we specify in this function variable, and trim call of alias. Okay, and here I'm gonna do one more step, That is actually to exclude if it like if the top 10 includes like NA, unknown. We don't want to see those values, so I'm going to exclude blank, null, or unknown entries. So how we are going to do that? We'll actually do the filter, and we will check that it's not null, and call alias it's not empty, and let's see, so they're not having values unknown, NA, none. So how we're going to do it, we'll actually first convert it to lower, and then we will check that this is not having values unknown, then we can have not available, and then or NA or none. Okay, okay, so that was we are having, okay, let's try to put this in parenthesis, so just to group like different conditions. Okay, and post that we will actually, okay, filter, so we'll need one more closing one for, okay, and then what we're going to do is we'll do the group by. Group by type. We have to calculate the top 10 based on the count okay, we'll call it count, and then we will order it by descending of count. Okay, okay, there is an error that I see, like because this filter is getting closed here, so I need to check what is wrong. Okay, let me close it here, then we don't need this. Okay, now it seems fine. So this is actually the function that we define. Now the next step is to get the top actors, directors on for top actors and directors. So how are we going to do it? We'll get the data. So actors is going to be get top by type, and we'll use the column cast, and then name, okay, so we'll call it name. Likewise for directors, by type, and then we'll do it on director column and name. Okay, so the next thing is actually to do this for different types, actually like the types like TV shows and movies. So how we are going to do it, we'll define another top 10 function where it's going to be df comma type name, and then return df.filter, let's say call of the call type name dot limit 10 to pandas. Okay, okay, then we will actually what we'll do is okay, so I think we actually I can see a flow. No, I mean, I think it can be actually made better if we return. So what change I will do is I will use window. So here, because we need to get each top 10 actors and directors by each type, so I think if you do the partition by window, it's actually going to get better. So for that, I'm gonna import window function. Okay, and change that I'm going to do here is okay, well, so we have now let's say we will actually define this as exploded. So we'll define it as another, so exploded is equal to, and we will try to get rid of this, and then I'm gonna okay, so we'll have to define a window. So window is going to be window dot partition by, and it's going to be type, and then order by descending of count. Okay, and the top n, or the top ranking, is going to be, so the top 10 is going to be exploder dot with column, and then rank, will define rank, so that's going to be row number over w, because we're actually ordering it from descending, and then we will filter only top 10. Okay, and then we will actually return top n without rank. Okay, so we will return only the top 10 ones. So now what we'll do is we'll actually get actors top 10 on window, which is actually partitioned by types. So on top, directors top 10, and then we can actually get rid of this top 10 function, and then we can actually directly get different data frames for actors movies. So that is going to be actors top 10 movies, then actors TV top 10, directors top 10 movies, and directors top 10 TV. So let's try to do that. Actors movies is going to be actors top 10, and we will only take when the type is going to be equal to movie, because we need only that, and then for plotting we'll convert it to pandas. So we'll do the same for directors and actors TV. Okay, it's giving us correct suggestions based on what we did. So I clicked on tab. So now we have for director movies and director TV. Super. Okay. So the next thing is that we need to plot subplots. So how we are going to do it, we will actually define fig and we can use make subplots. So this is a function that can be used, and here we define how many plots we will be having, subplots we'll be having. So it's going to be 4. So for each TV shows and movies, 2 each, and then so we define rows 2 and column 2, and we can define the titles. So it's going to be top 10 movie actors, and then top 10 TV show actors. Top 10 movie directors and top 10 show directors. So it's already suggested, and then we can actually specify some spacing to look it more readable. Also, horizontal spacing is going to be, let's say, 0.15, and vertical spacing is going to be again 0.15. Okay, so for in each subplot we will actually have a bar chart. So how we are going to add it, we will first define, because we need to add like the same bar chart for we need to have like 4 bar charts. So I'm going to define a function so that we have its reusability, and a row, column, then data and color. So let's say like we will use add trace. So this is actually the graph objects, and then we'll make use of graph.bar, and then x is going to be count, y is going to be name, or the top 10 actor or the actors or director's name, and orientation, it's better in this case to have its horizontal, and marker color, let's say using color, then row is equal to row and col is equal to col. Okay. Okay, so figure add trace. Okay, we don't need this. Okay, yeah. Next step is actually to add those charts. So we'll add all charts, and the first it's going to be add bar. So we'll add one by one, and the row and column, it's going to be actors movies. Okay, and we can specify a color. So I'm just specifying random color EF, let's say 5538. So it's going to be orange, and likewise we can do for all 4 actors TV. Yeah, okay, it's already suggesting us some colors, and let's use it. So next thing is actually to get a title, give title using update layout. Height, let's say 900, width, let's say 1100, and title text is going to be top 10 actors and directors by type. Show legend, let's not show legend, false. Okay, and we can use a template which is going to be simple white or plotly white. Okay, so let's fig.show. Super. Okay, I think we need to get the range reverse so that we can see the top to bottom. So yeah. How to do that? We can actually use fig dot update y axis. Auto range is going to be reversed. Okay, so here I can see in a column. Okay, let me try to find where that error happened. Okay, it looks like I made the error with closing parenthesis. So we actually put this closing parenthesis after lower. For lower, it should be here because we need to actually match the column alias values lower. So we need to actually like check if the lower value of this column is not in this one. So that's what we didn't do. So let's try to run it now. Okay, super. So if you look at this, we actually now don't have any unknown or NA values, and we get like the combinations or the names of top 10 movie actors, top 10 show actors, top 10 movie directors, top 10 show directors. So yeah, so that actually shows like analysis of actors or directors of different types. So this data set, from this data set, we can say that we actually pretty get, there is no such dominant actor. If you look at like the number difference, it is quite fine. It shows that actually like not one single actor is actually trying to have like majority of films or TV shows, etc. when we have like good mix here, which is really important. So that's so this was actually quite a bit lengthy because we used a subplot and then we actually did some using window values. So this is a good transformation example as well. So let's now go to the last. Okay, so it's question 6. So does Netflix have more focus on TV shows than movies? So let's try to find out if it's true. Okay, it's going to be question 6. Okay, let's try to find this out. And here what we need to do is we need to actually check the trend of TV shows. At the same time, we also need to check like how the trend goes for movies. So for that, I'll be using line chart, and let's first prepare the trend data. Okay, so here I'm going to define a trend data frame is equal to df dot filter call of, let's say, so we'll assume, or we'll actually give a check that it's not null. and then group by. So we'll have to actually have this by different types also, so it's easier. For each type we will check the added year and number. Okay, then we will show the count of star. Order by, we will order it by added year. And then we will convert this to trend PD. Okay, now we can actually plot. So we'll use fig is equal to px.line, and we will use trend PD. X is going to be added year, and Y is going to be the count. Color is going to be, so we'll have like different colors or different color for each type. So color type, and then markers, we'll put markers. And then let's put the title is equal to trend type over time. And we can put labels. We can actually change this added year to, okay, this, let's say added year is going to be year. Count is going to be, let's say, number of titles, and then let's say type content type, and then we can use a template is equal to broadly white. Okay, so the next part is like we always do, we'll actually just update layout. Okay, so height 600, okay, width 900. Let's say title font is equal to dict of size is equal to 20. And then legend title text is going to be of type. Okay, so that's it, I think. And let's close this and fig.show. Okay. Trend PD is equal to trend dot to pandas. Bad argument type. Okay. Okay, I think I found the where the error is. It's actually, I didn't put the double quotes here, so let me try to run. Okay, super. So if you see the Netflix content type over time, actually it is trying to say that, okay, 2025, because we don't have much data, so that's why actually you can see this dip in numbers. And if you look at 2024, where the movie numbers actually decline, but TV shows number is actually on the rise. So um, does Netflix have more focus on TV shows than movies in recent years? I'd say looking at the numbers, when we look at the numbers, we know that like movies, okay, even though we need to agree that this is not the real data set, but still, we actually, when we look at the numbers, we know that movies do actually, they still dominate. They have like when you look at the number comparison, movies actually number is much greater than the TV shows, but we cannot neglect the fact that TV shows is on the rise in recent years. Like it's actually picking up, so which is the actually the it is similar to what we see in real life. Actually, the number of TV shows have been on the rise, and when it's actually the many seasons one or the mini series, so it promotes the binge watching. And yeah, so TV shows are actually on the rise, but giving more focus. So the data that we have, it doesn't support that. If you look at, like, we have still movies are actually like in big number, a bigger number compared to that of TV shows. Okay, so now let's move on to the last part of, or the last question, before we try to analyze and find some insights. So let's try to understand. Question is, understand what content is available in different countries. So let's try to group them, kind of like, let's try to have a heat map for different countries and different content type or the genres. Okay, so for that, what we need to do is, like, well, like we always do, we actually, let's do this explode. First we'll do explode countries, and it's going to be, let's define a data frame heat, and then we will specify country, and then we'll give this explode, then split, call country, and okay. So we will also have it trimmed like we always do. Here dot with column country, and then we will trim call country. Okay, super. So we'll do the same for genres, and okay, super. So the next thing that we need to do is we'll actually get the, maybe we, because it's actually like, we'll have, if we're trying to show all the countries, maybe it'll have lots of data, so we'll just show the top 6. So we'll group by country, and then we'll have count, order by call of count, we'll take the descending, and then we will try to limit it to the top 6. Okay, and then we will do the inner join. So how we are going to do it, we'll heat is equal to heat dot join, select country, okay, and we'll do it on country and how it's going to be inner. And then we will actually, what we will do is we'll try to have the heat map based on top genres in each country. So for that, let's have a cross kind of thing where we do like, we'll try to do the heat dot group by on country, and then we will do the pivoting on each genre. Okay, so we'll try to calculate on each country level, and then we will check the we'll do the group by on genre on their counts. For all content types or the genre are actually taken into account in this one. Then we will use, so if in particular country there's let's say one country type, sorry, content type is missing, then we will actually fill that with 0, so that we'll have all different content types in each country. So the next step is plotting. So for plotting, what we need to do, we'll actually convert to pandas, and okay, and then we the next thing that we're going to do is, because we need to actually have that heat map color grading according to the order of each content type in each country. So the next thing that, let's say, we'll do is we'll actually try to find out grand total for each row. So how we are going to do it, we will normalized values is going to be cross pd dot div max of access is equal to 1. So we'll calculate its value by max for that row. Okay, and we will actually have list of countries. Countries is going to be, so because we need to have it for plotly, so that's what we're going to do it, try to show here to list, then genres, values, okay. Now let's try to show the plot. We'll use the fig is equal to, we'll use the graph objects, and then we will use go.figure. So data will be go.heatmap. Z is equal to values, because we need to have them. We need to grade, or we need to show them on Z level, values level. X is going to be genre, and then Y is going to be countries. Then color scale, let's say, is equal to, okay, let's say where it is. Z min is equal to 0 and Z max is equal to 1. So we'll trying to grade that. Okay, because it's actually normalized, so we are trying to have it in 0 to 1 range. Another thing maybe to actually update layout. So title is going to be by country, top 6. And then x-axis title is going to be genre, and y-axis title is going to be country, fig.show. Okay, so this is what we have, and then now let's try to run it. Okay, yeah, because group, okay, okay, it's actually it's listed in, sorry, yeah, it's not genre. Okay, another error. Okay, greater than or equal to, not supported. Okay. Okay, so here it looks like, actually, because it's a string and int, so one thing that we need to do is we need to actually set index, so that crosspd dot set index before doing this. So we shouldn't be getting error after doing this. Let's try in place equal to true. Okay, super, it looks like we get the value. So we know that so here if you look at this, it's how the heat map, and yellow is the color like when it's actually at the top. So in all countries, the content availability, in the drama category, the content type, or it actually has it tops the most. It actually tops in all countries, I would say. And when it comes to comedy, like actually in United States, in other countries, South Korea, Canada, United Kingdom, it actually better than it does in India or United States, and yeah. And so that's actually what it is. I mean, comedy, action, drama, they're actually in the green, yellow region, which actually shows that they have more. At the same time, romance and thriller also do have a good share, but still, I mean, the comedy, drama, and action. And if you look at the action, the from the data set that we have, United Kingdom, it doesn't show like it. It's actually does much. It's just like it is good because it is actually in a little bit of greener region than the yellowish region. So that means in other countries that content type does better. So yeah, so if we can actually do this analysis for each different content type and its availability in different countries. So I think we have answered all those 7 questions, and now it's the time for insights. So let's get into insights. Okay, so the first thing that we need to check is content type distribution. So, like I mentioned, yeah, from the data that we have, movies nearly 65%, and TV shows actually in 35%. So that means movies still dominate, but TV shows make up really 1/3 share. And TV shows, we have seen that on the rise in recent years. So this is the data that we have, and as a recommendation or based on data, so I would say keep let's say keep a healthy mix, because that has been doing good. And we all know that audience, because of TV shows and it's all seasons, and uh, the episodic content actually boosts retention. So that's why we so see that like TV shows on the rise. But yeah, always better to keep on the healthy mix, because TV's movie is still popular. Okay, so the next thing that we are gonna see is okay, trend of releases. So we can see that steep rise in releases. And recent years, I would say recent years shows growth. Yes. So as a recommendation, let's say like we saw that actually in case of TV shows, Q3 Q4 does better, right? Q3 Q4, so strategic releases do better. Okay, so the next thing is actually that we will check country wise. So because this is also very important, country wise content production. Okay, so yeah, for that let's go to our EDA, where we actually try to calculate top countries and production. Yeah, here it is, top countries. Okay, and yeah, okay, I think I did some change here. And if you look at this, we now have percentage, so it's easier to see how much percentage of like different countries contribute to the total content production. And here what I have done is I actually added a top countries percentage, where so this is something that we already had, where it actually calculates this is something that we already had, top countries dot to pandas, and then we calculate the percentage share, that is actually to total count we'll calculate, and then on that grand total we'll calculating the percentage level for each of it. So then we actually get a label, a column added, which actually takes into account the count and then percentage. Okay, so that's what this label is being added as a text, and then it's being shown here. So if you look at the top 10 countries, US of course is actually has the majority from our data, but if you look at Asia, so India, Japan, South Korea, so it's if you sum it up, 21 plus 5 is 26 for 30. So 30 percentage from Asia, which is actually a good number. So which shows that, okay, country wise content production, 30 percentage from Asia, from countries like India, Japan, South Korea. Okay, which actually shows it's a good global diversification. So as a recommendation, can say that increase maybe I mean to strengthen regional appeal for Netflix. It's important that local language originals, so content production in these different regions is also important, Asia and Europe. So yeah. So co-productions, let's say co-productions can also can capture, let's say, bilingual market, so it can be hit in different markets at the same time. Yeah. So yeah, this is another recommendation. And the next thing that we're going to see is genre. So genre popularity, if you look at it, like I actually tried to point out, so we had this top, after top countries we had top genres, and here also I did so top genre, actually if you look at the numbers we know that drama, comedy, action, so three of these actually do have a lot more content, or actually they are in the top 10 compared to other genre. So this drama, comedy, action, drama, comedy, action dominate. And yeah, so as a recommendation, maintain a strong investment in this genre, and also we cannot at the same time avoid having other genre also. And so if you look at, like, let's say documentary or sci-fi, they are also on the rise. I mean, they are also do come in top 10, like let's say after romance and thriller, documentary and sci-fi come before adventure, horror, so in our data. So this is actually also some niche genres that they shouldn't actually avoid. So let's say documentary or sci-fi to attract niche audience. Yeah. Okay. And another thing, we actually saw that top 5 top actors or directors. So we like I mentioned, names are diverse. So good for data variety. It is actually good for data variety. And as a recommendation, so use top recurring profiles in for recommendation engines. Or also, yeah. Okay, so this can be actually used for recommendation engines and also a combination of genre, country, which we did at the last, like what type of content in different countries, and also let's say the actor, let's say this combination can also be used for recommendation engines, so that it actually keeps users in, I mean, like more I would say, like stick on to Netflix more. So as a summary of recommendations, it's like increase regional co-productions, let's say, then prioritize, let's say, focus on TV series as well. TV series for binge watching, for binge friendly, let's say. Then maintain drama action pipeline, comedy. Let's say marketing, focus on marketing around the strong time, like the time to release, because we have seen that like Q3 Q4 is tends to be better time for release or release clusters. Focus marketing in for let's say releases. This can actually get more audience or more viewers. And let's say like a data recommendation engine or models using genre, country, actor trends. So this is actually a summary of the recommendation that we could get from the data exploration that we did. It may or may not differ from, because it's I would say it's realistic, but still it's just like demo data and it's not realistic real data. So the real things can vary, but from the data that we did, from the analysis that we did, these are actually the recommendation that we can give. And so that's it on this data project. So you have seen that actually we use the Windows function to get the top 10 for each different types, and then we also use different types of, like before visualization, different charts, subplots, and then histogram. So we did multiple combinations, and then majority of like group by, aggregation, then joins. So we try to do these transformation techniques to actually do the analysis in a better way. So that's it about I would say like this data project. And yeah, so please let me know your feedback, and thanks a lot for watching this. So see you in the next video.